Okay, so this is like the only exception to the rule I can think of. You know, I always said that if it's a gravity problem, oops, I need a pen here. If, oh, because I'm writing in black. There we go. Come on. There we go. I told you that A equals 9.8, correct? Negative 9.8 meters per second squared always. But just to let you know, that is on Earth, which pretty much all our problems are, correct? So the exception to the rule is when you're on a new planet. It's not. It's not A. It's not nine. It's not negative 9.8. That's only on Earth. That's because Earth is a certain size, and some planets have stronger gravity, and other ones have weaker. So here's a problem where it is not 9.8. If you land on a new planet, you are curious about the. Sorry about that. That's supposed to be the acceleration on the SNU world. You test it by dropping a tool from a height of 2 meters. So you grab a tool from your tool belt, you measure 2 meters high, and you drop it. So we know its change in displacement will be negative 2 meters. Okay, why is it negative? Because we're starting here, and we know it's going to fall downward, and it's going to move down, and its change in position will be negative 2 meters, okay? Because it did not move upward 2 meters, it moved down 2 meters, so negative 2. It takes 1.5 seconds to hit the ground, so t is equal to 1.5 seconds, and we're looking for a question mark, okay? What was its initial velocity? Don't forget this. It's actually 0, correct? We didn't throw it down. Notice that they say is dropping a tool. Dropping means you just hold it still and you let go. So it starts from a 0 meter per second position. So it's kind of, when you first let it go, it was 0 right here. Then it speeds up as it falls to the ground. So the only equation that's going to work with that is equation 3. And it's delta x is equal to VO times t plus 1/2 AT squared. Luckily, this is all 0 because initial velocity is 0. And just to let you know, that's the only way I'm going to do that, okay? Otherwise, you're going to have two t's and you need like a quadratic formula or something to solve it. And, that's a place for a regular classroom, not a summertime online class. You know what I mean? So, delta x is equal to 1/2 AT squared. And there we go. What do we do next? Oh, let's plug everything in. That's right. So let's plug it in here. Delta x is negative 2 is equal to 1/2 a, I don't know, time 1.5 seconds. So let's go ahead and multiply this all up. That's going to be 0.75 times a, because that's half of 1.5, is equal to negative 2. Let's divide 0.75, and let's divide by 0.75. And a is equal to negative because it's downward. So that's kind of common sense. And let's get a calculator out real quick. CALC, calculator. And let's type in 2, oops, not minus, 2 divided by 0.75. And I get 2.67. So this is rounding. 2.67 meters per second squared. And that is the acceleration on that planet, much weaker than Earth's. That's why it took 1.5 seconds just to fall from 2 meters, which is a little bit above my own height. All right, so go ahead and try a practice problem or two and see how you do.